Welcome to the new unit and the first video for linear inequalities and system of equations. So in this lesson, we're going to solve for linear inequalities with one variable. An inequality is a number sentence with two pieces that are not equal or that do not have the same value. So here are the symbols used to create or write inequalities. We have the greater than, less than, greater than or equal to, and less than or equal to sign. So usually your greater number is going to be on this side, and then your smaller number is going to be on that side. And it'll switch for the less than one. So the less one is going to be here instead, and your greater number is going to be here. The other ones just mean that it could also be equal to that number. So if we want to graph this, a greater than is going to be an open circle to represent that it can't be equal to that specific place. And then you're going to shade in everything that's greater than that number. If it's less than, something kind of similar, an open circle to represent that we're not including that number, and then everything less than that. Greater than or equal to is a closed-in circle, so we can indicate that that point is included, and then everything above it. Then less than or equal to, we include that point and everything below it. So we can also use inequalities in scenarios such as a jug can hold up to 4 cups of water. J can represent our jug, and it can hold up to, but not more than, 4 cups of water. So the jug is smaller than or less than the 4 cups of water. We can also build inequalities into equation. For example, what is x plus 3 when we know that x is greater than 11? Coming from this sentence, we know that x has to be greater than 11. Because we know x is greater than 11, we want to find what x plus 3 is. If I add 3 to both sides, I'm going to get x plus 3 on the left side. This doesn't change our inequality because we are adding 3 to both sides, not just one. And then we can simplify this. So 11 plus 3 is 14. So we know that x plus 3 is greater than 14. I want you to go ahead and try this activity. So write the correct sign to complete the inequalities. So write your greater than sign or your smaller than sign. Here's the solution to that. So 5 is smaller than 10. Negative 5 is greater than negative 10. You could also draw this on the number line to see why that's true. 4 is greater than negative 8. Negative 4 is smaller than 8. 2 is smaller than 3. Negative 2 is greater than negative 3. 12 is greater than negative 4. And negative 12 is smaller than 4. So if we look at the direction of each inequality, when the signs of the numbers change, the signs also switched as well. So if we have a negative 5 and negative 10 versus a 5 and 10, you can see our inequalities change directions. And same with having just one of the negatives. If they switched, we're going to change the directions for the sign as well. And we're going to use this fact later on in an example. In example 1, we want to solve for x, or for this inequality, and then also graph it. We're going to do what we usually do when we're solving for an equation. The only difference is if we divide by negative, then we have to switch our inequality sign because of what we just did over here. Okay, so I want to get x by itself. I'm going to subtract 7 on both sides. 16 minus 7 is 9. Then I'm going to divide both sides by 3. and that's a positive 3, so I don't need to switch my inequality sign. So my final answer is x is smaller than 3. We also need to graph this solution. We're going to create an open circle around 3, and x is smaller than that, so we're going to shade in everything that's smaller than 3. You could also draw it like this if you want to, just above it. That's okay as well. But remember to have the open circle because we cannot include 3. It's not a smaller than or equal to sign. For the next one, same sort of thing. We're going to subtract 1 on both sides to isolate our 2x, negative 2x. So 21 minus 1 is 20. Then to further isolate the x, I need to divide by negative 2. And the rule is you need to switch the inequality sign in the other direction whenever you divide by a negative. And our final answer is that x is smaller or equal to 10. If you want a little proof of this, I can show it to you. Let's just say that we have this inequality. Negative 3 is smaller than negative 1. That's certainly true. What if I want to divide by negative 1 on both sides? Then I'm going to get 3 is smaller than 1. Is that true? No. It's not true. That's why when you divide by a negative number, you have to switch the inequality sign so it's facing the other direction. Example 3. We're going to expand first and then simplify. Negative 7 times 2 is negative 14, and there's an x of that. Negative 7 times 1 is negative 7. This is smaller than 1. I want to isolate this negative 14x. I'm going to add 7 on both sides. And then I'll divide by negative 14 on both sides. And when you do that, remember to switch your inequality sign to the other direction. You can also simplify your fraction, which is the same thing as saying negative 4 over 7 if we divide top and bottom by 2. Just going to highlight this so that you know to switch your inequality signs because we divided by a negative there. In this next example, we have a compound inequality, and that is when we have an inequality that's made up with more than just one inequality in a row. I'm going to start off by writing exactly the question that we have. I want to isolate the x in the middle, this 2x plus 5. So to get rid of this 5, I can subtract both or every single inequality by 5. And then we simplify that. So this is negative 8, smaller than 2x. 17 minus 5 is 12. Lastly, we're going to divide every single inequality by 2 to get x by itself. So we have negative 4, smaller than x, which is smaller than 6, and that is your final answer. In our next example, very, very similar. I'm going to add 3 in every inequality, so I can get rid of that negative 3 in the middle. Negative 3 minus 1 is 2. You're left with a half x, and then 4. Now to get rid of this a half, I'm going to multiply by 2 to each inequality. That's 4. Smaller than x is smaller than 8, and that's our final answer. Lastly, for question 6, we have two inequalities and an or beside it. So we're going to solve for each separately first. I want to isolate my x. I'm going to add 1 to both sides here. -5 plus 1 is -4. Then we're going to divide both sides by 4, which is -1. Now we're going to focus on the other inequality. Same sort of thing. I want to add 1 to both sides. Then I got 6. Divide both sides by 4. So our final answer is x is smaller than -1 or x is greater than 3/2. And if you want to graph this out to see what this looks like, our x is smaller than -1 will look something like this. An open circle around -1 and shade in anything that's smaller than -1. And then an open circle at 3/2 or 1.5 and x is greater than that. So that means our solution set can be anywhere that's below -1 or above 3.